In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory when the conversation turned to UFOs and the possibility of extraterrestrial life. After listening to the discussion, Fermi suddenly asked a question that would haunt scientists for decades. Where is everybody? It was a simple question with profound implications. If the universe is 13.8 billion years old, and our galaxy alone contains over 400 billion stars, many with planets in the habitable zone, then statistically, intelligent life should be everywhere. We should see evidence of alien civilizations in every direction we look. We should be receiving radio signals, detecting megastructures, or at the very least, finding traces of interstellar travel. Instead, we've found nothing. Complete silence, as if we're alone in a galaxy that should be teeming with life. This is the Fermi Paradox, and it's one of the most disturbing questions in science, because the possible answers range from hopeful to terrifying. Let's start with the math because the numbers are staggering. The Milky Way contains between 200 and 400 billion stars. Conservative estimates suggest that at least 20% of those stars have planets in the habitable zone, the distance where liquid water can exist. That means there could be 40 to 80 billion potentially habitable planets in our galaxy alone, and the universe contains over 2 trillion galaxies. Dr. Frank Drake formalized this thinking in 1961 with what became known as the Drake equation. It attempts to estimate the number of communicating civilizations in our galaxy by considering factors like star formation rates, the fraction of stars with planets, and the likelihood of life developing intelligence. Even using conservative estimates, the Drake equation suggests there should be thousands, possibly millions, of intelligent civilizations in the Milky Way right now. But here's the problem. We've been listening for over 60 years, and we've heard nothing. The search for extraterrestrial intelligence, or SETI, has scanned millions of stars across multiple frequencies. They've found pulsars, quasars, and all kinds of cosmic phenomena, but not a single artificial signal from an alien civilization. The silence is deafening, and it's not for lack of trying. Since 1960, SETI has used increasingly sophisticated equipment to scan the skies. The Arecibo Observatory, before its collapse, could detect a signal from a civilization like ours anywhere within 1,000 light-years. We've looked for radio signals, laser pulses, and even massive engineering projects like Dyson spheres, hypothetical structures that advanced civilizations might build around their stars to harvest energy. The Kepler Space Telescope has identified thousands of exoplanets, many in the habitable zones of their stars. Some, like Kepler 452b, are so Earth-like that scientists call them Earth's cousins. Yet despite all this searching, all these potentially habitable worlds, we've found no evidence of intelligence anywhere in the universe except on Earth. This absence of evidence has led scientists to propose various solutions to the Fermi Paradox, and they fall into several disturbing categories. One possibility is that we're asking the wrong question. Maybe life isn't common at all. Maybe Earth is extraordinarily rare. The rare Earth hypothesis, proposed by Peter Ward and Donald Brownlee, suggests that while simple life might be common, complex life requires an incredibly specific set of conditions. Earth sits in the Goldilocks zone, not too hot, not too cold. We have a large moon that stabilizes our rotation and creates tides. We have Jupiter acting as a cosmic vacuum cleaner, protecting us from asteroids and comets. Our sun is stable and long-lived. Most importantly, we avoided the catastrophes that could have ended life before intelligence evolved. No gamma-ray bursts sterilized our planet. No massive asteroid impacts wiped us out permanently. No nearby supernovas irradiated our atmosphere. Maybe the combination of all these factors is so unlikely that intelligent life emerges only once every few billion years in a galaxy. Maybe we really are alone, or at least incredibly rare. But there's a more disturbing possibility: the Great Filter Theory. This suggests that there's some evolutionary step that's nearly impossible to pass, and most life forms go extinct before reaching it. The question is, Where is the filter? If it's behind us, if the hard step was developing complex cells or multicellular life, or intelligence itself, then we're incredibly lucky to have made it this far, and we might indeed be alone. But if the great filter is ahead of us, that's terrifying. It would mean that virtually all intelligent civilizations destroy themselves before they can spread to the stars. Looking at human history, this isn't hard to imagine. We've developed nuclear weapons. We're changing our climate. We're creating artificial intelligence that might surpass us. Maybe every civilization reaches a point where their technology becomes powerful enough to destroy them, and very few survive. Science fiction author Liu Cixin proposed one of the most chilling solutions, the dark forest theory. It suggests that alien civilizations do exist, but they're all hiding. The theory works like this. In a dark forest, every hunter stays silent because making noise reveals your location to other hunters who might kill you. Similarly, any civilization that broadcasts its location to the galaxy risks being destroyed by a more advanced civilization that sees them as a threat. According to this theory, the galaxy is full of civilizations, but they're all staying quiet, listening, and occasionally eliminating any civilization foolish enough to announce its presence. This would explain why SETI hasn't found anything, and it suggests that our own radio broadcasts over the past century might have been a terrible mistake. A more benign possibility is the zoo hypothesis. Maybe advanced civilizations do exist, but they're deliberately avoiding contact with us, like researchers observing animals in a nature preserve. Perhaps there's a galactic civilization that has agreed not to interfere with developing species like humanity. We're being watched and studied, but from a distance, until we reach some threshold of technological or social development. This would explain the UFO phenomenon, occasional observations by alien researchers, who are trying to stay hidden but sometimes get spotted. Another possibility is that advanced civilizations transcend physical reality entirely. Once a species develops artificial intelligence that surpasses biological intelligence, they might focus inward rather than outward. Instead of building starships and colonizing the galaxy, they might create virtual worlds so compelling that they lose interest in the physical universe. Why explore space when you can create infinite digital realities? This could explain why we don't see evidence of galactic engineering projects. Advanced civilizations might exist, but they're all living in simulated realities, having abandoned the physical world entirely. There's also the possibility that we're simply early to the party. The universe is 13.8 billion years old, but the first stars were mostly hydrogen and helium. It took several generations of stellar death and rebirth to create the heavy elements necessary for rocky planets and complex chemistry. Maybe the conditions for intelligent life have only recently become common in the universe. Maybe we're among the first intelligent species to evolve, and in a few million years, the galaxy will be teeming with civilizations. Each solution to the Fermi Paradox has disturbing implications. If we're alone, then the universe is a vast, empty place, and the responsibility for preserving consciousness and intelligence rests entirely on our shoulders. If the great filter is ahead of us, then our future is likely extinction. If the dark forest theory is correct, then we've already made a fatal mistake by announcing our presence to the galaxy. Even the more optimistic solutions are troubling. If we're in a zoo, then we're not truly free. If advanced civilizations have transcended physical reality, then our dreams of exploring the stars might be pointless. Despite the paradox, the search for extraterrestrial intelligence continues. New projects like Breakthrough Listen are scanning millions of stars with unprecedented sensitivity. The James Webb Space Telescope is analyzing the atmospheres of exoplanets, looking for biosignatures. Maybe we'll find microbial life on Mars or Europa. Maybe we'll detect an artificial signal from a distant star. Maybe we'll discover that the galaxy is full of life, but it's so different from us that we haven't recognized it yet. Or maybe Fermi was right to be puzzled. Maybe the silence really is as significant as it seems. The Fermi Paradox forces us to confront uncomfortable questions about our place in the universe. Are we alone? Are we early? Are we doomed? The answer matters because it shapes how we see ourselves and our future. If we're alone, then every human life, every work of art, every scientific discovery is precious beyond measure. We might be the only conscious observers in a vast, unconscious universe. If we're not alone, then we need to decide how to proceed. Do we keep broadcasting our presence, hoping to make contact? Do we stay quiet and listen? Do we prepare for the possibility that we're not the most advanced species in the galaxy? One thing is certain. The Fermi Paradox is more than just a scientific puzzle. It's a mirror that reflects our deepest fears and hopes about what it means to be human in an infinite cosmos. The universe is vast and ancient, full of billions of worlds where life could flourish. Yet as far as we know, we're the only ones asking where everybody is. Maybe that's the most remarkable thing of all. What do you think is the solution to the Fermi Paradox? Are we alone? Or are we missing something obvious? Let me know in the comments. If you enjoyed this exploration of one of science's greatest mysteries, subscribe for more deep dives into the questions that keep scientists awake at night. Until next time, keep looking up.